Hi, my name is Matson Leonard. Today, I'm going to walk you through on how I solved my combined spectral problem and determined the structure of an unknown compound using its molecular formula, degree of unsaturation, IR spectrum, C13NMR, and proton NMR. My molecular formula for my unknown is C6H12O2. And when I calculated my degree of unsaturation, I received a value of 1. This information tells me a lot. It tells me that there could be either a ring or a double bond that could be found within my unknown structure. However, since there is oxygen present, it's more likely that there's going to be a carbonyl double bond rather than a ring present within the structure. Next, let's take a look at the IR spectrum. There's a strong peak located around 1750, which is a characteristic of the carbonyl group, specifically consistent with an ester carbonyl, located here. Next, there are some strong CO peaks between 1050 and 1175. These further suggest the presence of the ester. Thirdly, the peak around 2950 indicates the sp3-CH bonds that are stretching. This suggests that there would be alkyl chains rather than alkenes or aromatics within the structure. In conclusion, from just the IR spectrum alone, I can easily say that this compound is going to be an ester. In our carbon-13 NMR, the most downfield signal appears at 750 ppm. This corresponds to the ester carbonyl carbon. There's also a signal around 65 ppm, which is consistent to the carbon that's bonded to the oxygen. Next, the remaining peaks that fall between 9 and 24 ppm are typical of sp3 alkyl chains. Altogether, there are 6 distinct carbon environments, which match the 6 carbons that are located within our molecular formula. Finally, looking at our proton NMR, there is a signal around 4.1 ppm, integrating 2 hydrogens. This signal is consistent with the oxygen that's bonded to the CH2 group in the ester. At around 2.4 ppm, there is another 2 proton signals that match a CH2 group that would be adjacent to a carbonyl. The signal around 1.8 ppm is a sextet that is integrating 2 hydrogens, which suggests a CH2 group located in the middle of an alkyl chain. Last but not least, there are 2 triplets around 1.2 and 1 ppm, each integrating 3 hydrogens. These would indicate that they would be methanol terminal groups. I would also like to note about the splitting patterns and integrations are all consistent with straight alkyl chains on both sides of the ester. Based on just this information alone that I've gathered from my molecular formula, my degree of unsaturation, my IR spectrum, my C13NMR, and my proton NMR, the structure that best fits my data is an ester. Specifically this one. This proposed structure accounts for the single degree of unsaturation that I found in the beginning of this problem, as well as all 6 carbons, and both oxygens that were included within my molecular formula, as well as every NMR signal observed. So by combining my IR, my CNMR, and my HNMR, data, I was able to confidently identify the unknown compound as an ester with 2 alkyl chains.